Imagine having to call a restaurant every 5 minutes just to see if your food is ready. I mean, that's literally how older IT networks used to report errors. Today, we are looking at how modern networks use push notifications instead, as we do a deep dive into the HPE6-A90 exam.
Right, and we're going to take a deliberate, measured approach to analyzing these scenarios, just to make sure you truly understand the logic behind the architecture. We won't rush it.
Exactly. Let's just jump right in. Question 1. An administrator wants to automatically notify a third-party IT service management application whenever a critical network gateway goes offline. Which mechanism provides the most efficient real-time integration for this requirement? The correct answer is B.
Yeah, so that would be outbound webhooks. This is all about event-driven architecture.
Right.
Instead of the management system just, waiting around to be pulled for an update, the exact moment a gateway drops, a webhook pushes an HTTP-based notification
Directly to the external application, like your ITSM platform, in real time, which goes right back to that push notification idea we mentioned. It's instant.
Exactly. And just like a push notification saves your phone's battery, a webhook saves massive amounts of network bandwidth because it only transmits data when an event actually happens.
Oh, wow, that makes perfect sense. So we've automated our gateway alerts. But what happens when the issue isn't a hard outage, but like a ghost in the machine? That brings us to question 2. If intermittent connectivity issues are affecting multiple clients across a large campus, which analytical capability within the management interface is best suited to identify the historical root cause without relying on manual packet captures? The correct answer is C.
Right, machine learning-driven network insights. The real keyword you want to look at here is intermittent.
Right, because it comes and goes.
Right. If an issue isn't happening right at the exact second you look at a live utilization graph, human eyes will completely miss it.
Yeah, I mean, nobody has time to just stare at live telemetry all day hoping a blip happens, right?
Precisely. So machine learning analyzes that historical telemetry over time to spot hidden patterns that are, well, practically invisible on a live dashboard.
Let's move from software analytics down to the physical hardware. Question 3. What is a primary operational benefit of configuring multiple physical switches into a single logical stacking entity through the cloud management platform? The correct answer is C.
Switch stacking. It radically simplifies administration by presenting a single management interface.
Okay.
You're basically telling the management platform to treat several individual physical boxes as one single logical device.
Which is a lifesaver, because I'm sure nobody listening wants to spend their Friday night applying the exact same firmware update to 8 different switches individually.
Definitely not.
And that logical approach actually shifts how we think about the entire network. Question 4. Which security framework leverages centralized policy enforcement to dynamically assign appropriate network access privileges to an Internet of Things device regardless of the physical port it connects to? The correct answer is A.
Colorless ports.
But wait, I have to ask. Historically, wasn't security rigidly tied to where you physically plugged into the wall?
It was, yeah, and this is a massive paradigm shift. Yeah. Colorless ports completely changed that logic. Now, the network authenticates the device first.
Oh, I see.
And then it dynamically assigns the correct role in VLAN based on its identity, totally independent of its physical geography.
Right. But even with identity-driven security, we still have to worry about the physical realities of the hardware, Question 5. An administrator needs to quickly identify if a sudden increase in temperature is affecting the performance of a specific wiring closet switch. Which dashboard area provides this hardware-specific environmental data? The correct answer is D.
That would be the individual device health monitoring tab. Global overviews are fantastic for broad client trends.
But not for physical stuff.
Right. Things like temperature spikes or fan statuses are highly localized. You really have to drill down into the specific device's dashboard to diagnose physical environmental issues.
Got it. Let's zoom out to how traffic actually flows from those devices. Question 6. Which traffic forwarding model should an architect select if the goal is to have wireless access points drop user traffic directly onto the local wired network without encapsulating it to a central controller? The correct answer is A, but I will admit bridge mode forwarding feels kind of counterintuitive.
How so?
Well, why wouldn't we want to securely tunnel everything back to a central controller?
Well, because sometimes tunneling creates an unnecessary bottleneck. If you want a local breakout at the access layer, meaning you want the access point to just drop client traffic directly onto the local wired VLAN, bridge mode provides the most direct, efficient path.
Okay, but if we are dropping traffic locally, how do we keep it safe? Question 7. When migrating legacy wireless networks to the latest cloud-managed architecture while implementing enhanced personal security protocols, which feature provides individual encryption keys for open networks? The correct answer is B.
Enhanced open security. It basically takes open networks where you don't need a shared password and automatically adds encryption underneath.
Using opportunistic wireless encryption, right?
Exactly.
Wait, does this function similarly to a built-in VPN for public Wi-Fi, like securing the connection even without a password prompt?
Conceptually, yes. It creates a unique key for each user, providing an individual layer of privacy on what would otherwise be unprotected airwaves.
We have covered everything from webhooks to bridge mode today, but it leaves you wondering, as the network becomes entirely identity-driven and cloud-managed, are we engineering the traditional network administrator right out of a job? To summarize our core coverage for the HPE6-A90 exam, we analyzed webhooks for real-time alerts, machine learning insights for historical patterns, switch stacking for unified management, colorless ports for dynamic access, hardware monitoring for localized metrics, bridge forwarding for local breakouts, and enhanced open security for encrypted public access.